Okay, so welcome everyone back from the coffee break. I'm Mark Plumbley. I'm going to be introducing my colleagues Yin Cao and Saeid Safavi. We're from University of Surrey. And so we're going to be doing a couple of demonstrations about sound recognition of generalization that will lead into those of you that are staying here for the DCASE workshop on detection and classification of acoustic scenes and events over the next couple of days that Juan Bello and his team from NYU are hosting that. So as we wait for the display to connect up, notice the microphone here. It's a real microphone that looks like a microphone. So at this point, I'll just say a little bit about the project. So this is a project that we've been hosting at Surrey for the last 3 years or so, working with colleagues at the University of Salford near Manchester, really about the basic technology of recognizing sounds. And this was a couple of things that we found have helped us when we're explaining things, particularly to people in a wider audience, about the sorts of things that the technology is now capable of and what sort of things that might help people to do. So at this point, I'll hand over to Yin. Over to you.
Hello, everyone. As Mark talked, this is a project of ours in university at the University of Surrey. I'll first talk about our first demo, which is a general purpose sound recognition. As we all know that, this generalized sound recognition has many applications. So it can be used in security, surveillance, smart home, smart car, industry detection, and health. I'm not going to talk about details about these applications, but just want to show you some demos. So actually, our demos is able to detect over 500 classes of real sound, and the labels are based on audio set labels. And the demos will show the top six most probable sound events, and together with corresponding confidence. So this is the interface of our demo. You can see that because I'm talking now, so most of the cases is speech now. So I would like to ask all of us to try to keep as quiet as possible, so because the system actually picks up all of the sound. Next up, I will play some samples of some audio samples, but you are also welcome to try it by mimicking any sound yourself. As you can see, there's a piano showing up. Most of the cases, it's music. And let's try next one. So basically, it's a bird sound. So, I think we can hand it over to my colleague for the next demo, which is some generalization and visualization.
So hello everyone. The next demo that I'm going to present is about the demo that actually we developed as part of the Making Sense of Sound challenge. So actually the full details about this demo and this challenge is accessible from Making Sense of Sound website as well. So this demo is actually about challenging the capability of machine to replicate the human ability in order to generalize the audio files. So the main task is to classify the audio data as belonging to one of these 5 major categories, named as nature, music, human, sound effects, or urban. So these categories on these groups, they're specified by our partner, University of Salford. They did some psychological tests using the human listeners to end up with these 5 major categories. So the demo that I'm going to show you is actually able to classify the audio files to belong to one of these 5 categories, and it can be used, actually can analyze the data from pre-recorded audio files, and it can also analyze the data by recording it from the interface and analyzing it afterwards.
Exit.
So I'm going to load a file, the pre-recorded file, and you can see how it works in action. So this is the music clip. And when we analyze the file, it's just analyze it as a music category, so it can easily generalize the file. So another example would be just a laugh clip. So it is the human laughing, so it should go through the human class with relatively high accuracy. And we also tested it for sound files, which has a mixture of source types in it, like this file. So it contains a mixture of source types files like music, nature, some human sounds going on in the background. And when we analyze, we can see the confidence measure for each of these classes in the generalization demo. So it's mainly music, but it also contains some urban and some nature sounds in the background, and also humans. So apart from this one, and using the same framework, but actually doing some application out of it, so creating some applications out of this framework is another way of representation for audio files. So as you can see on top, there are 2 conventional ways of representing audio files, but one of them is waveform, and one of them is spectrograph. So for ordinary users, they can't really understand that much from those 2 representations. So that's why we ended up with a third representation, which is the block type of representation. So we analyze each segment, which are equal to 3 seconds, and each of these segments contains boxes with different size and different color. The color represents the event at that particular segment, and the size represents the dominance of that particular event within that time frame. So it works actually like a table of contents for the audio files, so people can see what's inside the audio files without even need to listen to the whole section. So I'm going to show you one example for the visualization as well. So again, this is the audio file mixture of nature. So start with the nature sounds, and then the music starts, music ends, nature continues. And you can see the pattern of these sounds on the diagram. So you can easily pick that in the middle of all music. So that was our demos actually. So thank you very much for listening.
Thank you.